Show using calculus that the area of a circle is pi r squared. This is a formula that we all know. The area of a circle is pi r squared, but it can actually be proved using some calculus. So if we draw an xy axis and place a circle on it, and we let the circle have radius r, so this point will be 0, the centre of the circle. This will have a coordinate r. And this would be minus r. Similarly, this would be minus r, and this would be r. And then if we take a point on the circle, which is x, y, and then draw this sort of right-angled triangle, then this distance here is going to be x, this distance here is going to be y, and this is the radius of the circle. And then using Pythagoras' theorem, we can say that x squared plus y squared is equal to r squared. And if we rearrange that, we get the equation of the top part of the circle, which is y is equal to the square root of r squared minus x squared. If you want the bottom part, then you just make this minus. Now, if we say that the area of the circle is 4 times the shaded area, then we can set up an integral. So the area will be 4 times the integral from 0 to r of this function, which is the square root of r squared minus x squared dx. Now, to integrate this, we need to use integration by substitution. So we let x be equal to r sine theta, and then with integration by substitution, we normally differentiate that, so we get that dx d theta is r cos theta, r just being a constant, and the differential sign is cos. Then we rearrange this for dx. We're going to get that dx is going to be equal to r cos theta d theta. It's also useful to change the limits, 0 and r. So the limits, when x is equal to 0, so this r sine theta will be equal to 0. Okay, and then for sine theta to be equal to 0, theta would have to also be equal to 0. And then when x is equal to r, then we're going to have the r sine theta is equal to r, and therefore sine theta will be r over r, which means that sine theta is equal to 1, and that means that theta would be pi over 2. Don't forget, we've got to use radian measure because we're using calculus here. So that's 90 degrees, but with pi over 2. So now rewriting the integral, we're going to have 4 with new limits from 0 to pi over 2, the square root of r squared. Now we're going to replace with x squared, x with r sine theta, so therefore x squared will be r squared sine squared theta. And then dx we're going to replace with r cos theta d theta. Now this looks quite complicated, but actually it's quite easy. Now there's a common factor here of r squared. Once you take it out of the square root sign, it becomes r. But if you combine it with that r, it becomes r squared. And then in the square root sign, we now have the square root of 1 minus sine squared. And here we have cos theta. So I'll just repeat what we did there. We took out a common factor of r squared. Outside the square root sign, it becomes r. But combined with this r here, it becomes r squared. Now, okay, so working with that same integral, we now need to use the trig identity. We know that sine squared plus cos squared is equal to 1, which means that cos squared theta is 1 minus sine squared theta. So we've now got 4r squared. Under the square root sign, we got the square root of cos squared theta, because that's what 1 sine squared theta is. We still got that other cos theta d theta there. And therefore, we can take the r squared out of the integral sign because it's just a constant. And then if you've got the cos squared and you take the square root of it, you got cos theta. And then if you combine it with the other cos, it becomes cos squared again. So just repeat that. You take the square root of the cos squared, you just get cos theta. But cos theta times cos theta gives you cos squared theta. Now, to integrate cos squared theta, you need to use this identity that cos 2 theta is equal to 2 cos squared theta minus 1. And then we rearrange it for cos squared theta. And we go cos squared theta is a half of 1 minus cos 2 theta. Just pause the video here to check that for yourself. So I'm going to put that half underneath the 4 here because it's just a number. So we've got 4 over 2, the integral from 0 to pi over 2, and they're going to replace the cos squared with the 1 plus 2 theta d theta, and the half being outside. 4 divided by 2 is 2, so we've got 2 squared. If we integrate 1 with respect to theta, we get theta. And if we want to integrate cos 2 theta, it comes from sine 2 theta. And if we differentiate this, we're going to get 2 cos 2 theta. So we've got 2 times too much, so we need to put a half in front of that. So this is integration as the reverse of the chain rule. So we're going to get a half of sine 2 theta, and now the limits now go at the end here from 0 to pi over 2. Pause the video, just check that for yourself that you need that extra half there. Okay, so carrying on, we're going to get a is 2r squared theta plus a half sine 2 theta, and we're now going to substitute these limits in. So we're going to get 2r squared, theta is pi by 2, plus a half of sine of 2 theta. So 2 times pi over 2, this gives you pi. Now, we now need to subtract theta being 0, and this being equal to 0. So half of sine 0. We should put in the half there. Now, the good thing is that sine of pi is 0. 0 is obviously 0, and half of sine of 0 is also 0. So we're just left with 2r squared times pi over 2. The 2's were cancelled, and lo and behold, we're left with the formula for the area of the circle, which is pi r squared. So this has been a video to show you how to find drive the area of the circle formula using integration. I hope you've understood, and maybe you could, if you got this far, maybe you could consider subscribing to my channel, and you will find the link to all my other videos in the link of this video. Thank you very much for watching.